Hello viewers, in today's class we are going to discuss a very important concept in three-dimensional geometry, right? We have also discussed this concept in our earlier videos, but here we are going to solve an important problem from this topic, that is to find the foot of the perpendicular and image of the point with respect to a plane, right? So viewers, here we have the problem. Find the foot of the perpendicular drawn from the point. The point is given as p1 comma minus 2 comma 4 on the plane 2x minus 3y plus 5z plus 10 is equal to 0, right? And we have to also find the length of the perpendicular and image of the point, this point with respect to this plane, right? So let us start. Now viewers, here we are given a point P, right? So this is the point P. The coordinates are 1, minus 2 and 4, right? And here we are given a plane. This is the plane whose equation is given by 2x minus 3y plus 5z plus 10 is equal to 0. And we have to find the foot of the perpendicular, right? So the foot of the perpendicular is drawn from this point to this plane. So this is the perpendicular, and let M be the foot of this perpendicular PM, right? Okay, so we have to find the coordinates of this point M. M is the foot of the perpendicular, right? And the perpendicular is PM. So let us assume the coordinates as alpha, beta and gamma, right? And moreover, we have to find the image of this point P with respect to this plane, right? So this is our plane and this is our given point, and here we have to find the image of this point P with respect to this plane, and this plane will act as a mirror, right? So the image of this point P, it comes out to be here, and let us take this point as P dash, right, or P prime. So P prime is the image of this point P, right? And we can take it as image, and let us assume the coordinates of this point P prime as P comma Q comma R, right? So viewers, this is the situation. We are given a point P and a plane. We have to find the foot of the perpendicular M, which is the perpendicular is drawn from this point P to this plane, and moreover we have to find the image of this point P with respect to this plane, and the image is P prime or P dash, right? So we have to find alpha, beta, gamma and P, Q, R. Now viewers, we know that the important component of a plane is its normal, right? So here we are given the equation of plane as 2x minus 3y plus 5z plus 10 is equal to 0, right? And the normal to this plane is like this, right? So this is the normal vector to this plane, right? And the direction ratios of this normal vector, right? The DRs of the normal vector n cap, or we can take vector n, are given by the coefficients of x, y and z, right? So the direction ratios of this normal vector are given by 2, minus 3 and 5, right? So always remember, if the equation of a plane is given in the form ax plus by plus cz plus d is equal to 0, then the direction ratios of the normal vector are given by the coefficients of x, y and z. So here we have 2, minus 3 and 5, right? And moreover we observe here that this normal vector, right? This normal vector n cap is parallel to PM, right? Because PM is the perpendicular to this plane, and the normal vector is also perpendicular to the plane, right? So these two vectors are parallel, and from vectors we know that if two vectors are parallel, then their direction ratios are either equal or proportional, right? So here we can take the drs of this line PM. Drs of PM can also be taken as 2 minus 3 and 5, right? So what we have done here, the drs of this vector, that is n cap, are 2 minus 3 5. PM is perpendicular to this plane, and this normal vector is parallel to PM, right? So when two vectors are parallel, then their drs are either equal or proportional. So we may take the drs of this perpendicular PM as 2 minus 3 and 5. And now let us write the equation of this line PM, right? Because we have already obtained the drs of PM. Now viewers, we know that the equation of a line passing through a point x1 y1 z1 is given by x minus x1 over a, y minus y1 over b, and z minus z1 over c, right? So the equation of a line which passes through x1 y1 z1 and whose direction ratios are a, b and c is given by this equation, right? So here the equation of PM can be written as x minus x1 y1 z1. So this point x1 y1 z1, we can take 1 minus 2 4 as x1 y1 z1. So we have x minus 1 over see the drs of the line PM are 2 minus 3 5. So we have x minus 1 over 2. Then we have y plus 2 over minus 3 and z minus 5 over here we have 4. So we have z minus 4 over 5, right? So the equation of this line PM which passes through 1 minus 2 4 and whose drs are 2 minus 3 5 is given by this equation, right? Now viewers, let us apply the concept of general point, right? General point. Now see, the equation of PM is given by this equation, right? So if we take a scalar r here, then we can have the equations x minus 1 over 2 is equal to r, y plus 2 over minus 3 is equal to r, and z minus 4 over 5 is equal to r, right? So here we are taking this scalar r to find out the coordinates of a general point on this line PM, right? And that general point will be taken as this point M in our later steps, right? So here we will take r and we have framed these three equations, right? So from here we have x is equal to 2r plus 1. Here we have y is equal to minus 3r minus 2 and z is equal to 5r plus 4, right? So now we have the coordinates of the general point as 2r plus 1 minus 3r minus 2 and 5r plus 4, right? And this general point lies on this line PM, right? And for some value of r, this general point may be this point M, that is alpha, beta and gamma, right? So for some value of r, this general point will represent this point M. And now if we compare both sides, we have alpha is equal to 2r plus 1, beta is minus 3r minus 2 and gamma is 5r plus 4, right? So the coordinates of the foot of the perpendicular, which is M, are given by alpha, beta, gamma in terms of r, right? And now we have to find this value of r, right? So here in order to find out the value of r, we have to make use of one more important concept. Now viewers, let us see that this point M lies on this line PM, right? And at the same time this point M also lies on the plane, right? Because this point M is the foot of the perpendicular, right? So this point M lies on the line PM as well as on the plane. So therefore this point M, which is alpha, beta, gamma, must satisfy the equation of the plane, right? So we have 2 alpha minus 3 beta plus 5 gamma plus 10 is equal to 0, right? So alpha, beta, gamma is the point which lies on the plane. So this point alpha, beta, gamma must satisfy the equation of the plane. So now we can substitute alpha, beta, gamma from here. So we have 2r plus 1, then we have minus 3r minus 2, and then we have 5, and here we have 5r plus 4 plus 10 is equal to 0, right? And now we can solve this equation in r. So we have 4r, then we have 2, then we have 9r here, and plus 6, then we have 25r, then we have 20 plus 10 is equal to 0, right? So here we have 4r, 9r and 25. So this is 25 plus 9 is 34 plus 4 38r, right? And here we have 6 plus 2 8 plus 20 28 plus 30 38, right? So now we have 38r plus 38 is equal to 0. This is 38r is equal to minus 38, and r is equal to minus 38 over 38, and that is equal to minus 1, right? So now viewers, the value of r is equal to minus 1, right? And if we substitute this value of r over here, we get alpha is equal to 2 times minus 1 plus 1, beta is minus 3 minus 1, here we have minus 2, then gamma is 5r plus 4, so we have 5 times minus 1 here and plus 4, right? So this is minus 2 plus 1, this is 3 minus 2, and this is minus 5 plus 4. So this is minus 1, this is 1, and this is minus 1, right? So viewers, the coordinates of the foot of the perpendicular, which is M, are given by alpha, beta, gamma. So the coordinates of M are given by minus 1, 1 and minus 1, right? So now we wish to find out the distance PM, and PM is the length of the perpendicular. So PM is calculated by using the distance formula, and the distance formula is square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, right? So now we can take the values of x1 y1 z1 as c x1 y1 z1 can be taken as this point P, which is 1 minus 2 4, and x2 y2 z2 can be taken as this point M, which is minus 1 1 and minus 1, right? So now substituting x1 y1 z1 and x2 y2 z2 in this formula, that is the distance formula. So we have PM is equal to square root of minus 1 is minus 2 square 1 minus 2, that is plus 2, so we have 3 square, and here we have minus 1 and minus 4, that is minus 5 square, right? So this is 4, this is 9, this is 25, so this is 13 plus 25, that is square root of 38, right? So viewers, the length of the perpendicular PM is given by square root of 38 units, right? So now let us find out the coordinates of the image, that is P dash. So now viewers, we know that the point P and this point P dash, they are equidistant from this plane, right? Because this plane acts as a mirror, so the object and the mirror are equidistant, the image are equidistant from the plane, right? So now see, here we have this point P, that is 1 minus 2 4, and this is the point M, that is alpha beta gamma, which we have obtained as minus 1 1 and minus 1, and this is the image, that is P dash, and the coordinates P Q R are to be calculated. So now viewers, this is the situation. So we have this line segment, that is P dash, and M is the midpoint of PP dash, right? So PM is equal to MP dash, and we can here apply the midpoint formula. So minus 1, that is we can take alpha is equal to 1 plus P over 2, beta can be taken as minus 2 plus Q over 2, and gamma can be taken as 4 plus R over 2, right? So here we are applying the distance formula, and the distance formula is x is equal to x1 plus x2 over 2, then y is y1 plus y2 over 2, and z is z1 plus z2 over 2, right? So this point can be taken as x1 y1 z1, this point can be taken as x2 y2 z2, and this point can be taken as x, y, and z, right? So alpha is minus 1, beta is 1, and gamma is minus 1, right? So now we can solve these three equations to get the value of P, Q, and R. So 1 plus P is equal to minus 2, and minus 2 plus Q is equal to 2, and from here we have 4 plus R is equal to minus 2, right? And now if we solve, so P is minus 2 minus 1, that is minus 3, Q is 4, because minus 2 when we take minus 2 to this side, so 2 plus 2 4, and here R is minus 2 minus 4, that is minus 6, right? So viewers, the coordinates of the image of this point P, which is PQR, are given by minus 3, 4, and minus 6, right? So these are the coordinates of this point P dash, right? So viewers, this is how we solve this important problem.